What does it really mean for an AI to think? Today, we're diving deep into backend engineering, the digital foundation. The digital economy runs on backends. Every purchase, message, stream demands for real time, always on, globally consistent services have exposed hard limits in traditional architectures. Backend engineering is now the critical lever for resilience, velocity, and customer trust. Modern applications require sub-10 P99 reads, 5 nines availability, and safe continuous deployment. Data consistency, infinite scale, and developer agility can no longer be traded off. The event-native approach makes them coexist. Only an event-driven, log-centric backbone meets these demands. The shift is not evolution, it's the new baseline. Establishes back-end engineering as the strategic foundation and frames the necessity of an event-native architecture. But here's where it gets interesting, the reliability-velocity chasm. Microservices delivered independent deployability, but fractured state. Distributed transactions, sagas, retry storms introduce inconsistency and operational toil. Transaction boundaries leak across services, causing partial failures and corrupt state. Workarounds like outbox patterns add complexity, not safety. Service meshes handle communication, not data consistency. Reliability remains hand-built, scaling with fragility. Fast iteration and guaranteed consistency have been opposing forces. SRE burden grows superlinearly. Today's platforms force an unacceptable choice: ship fast or stay reliable. The engineering cost of reconciling them is too high. The backend must break this trade-off, articulates the gap between delivery speed and reliability that current architectures fail to close. So what's the real problem? Let's talk about root cause: synchronous coupling and immutable state. Request-response chains create deep dependency graphs. A downstream timeout cascades, exhausting threads and causing retry amplification. Distributed coordination via two-phase commit imposes blocking, limits throughput, and sacrifices availability. The root cause is mutable, shared state accessed synchronously, a design that cannot scale or self-heal. Consistency is maintained through locks and leader election, single points of failure. This architecture forces developers to write fragile compensation logic. The fundamental mismatch between modern load patterns and synchronous state management is the failure origin. As systems grow, the coupling surface expands geometrically, making changes risky and slow. Traces fragility directly to synchronous state access and distributed coordination. This raises a critical question: breakthrough, event sourcing and CQRS as primitives. Decouple writes from reads. Every change is an immutable event appended to an ordered log. Business logic becomes pure, idempotent handlers that derive new events. Read models are materialized asynchronously from the event stream. This eliminates distributed locking. The log is the source of truth, providing audit, replay, and rebuilding of any state. Consistency is achieved by sequential event processing within a partition. No distributed coordination required. The architecture enables independent scaling of write and read paths, time travel queries, and exactly once processing by design. Past state is never overwritten. Every decision is traceable. Failure recovery becomes deterministic replay. Introduces the fundamental architectural leap that resolves the coupling and state consistency problems. Now let's zoom in on system, event-native runtime mesh. The backend is a fabric of event logs, stream processors, and materialized views. An API gateway accepts commands, validates idempotency, and appends to sharded log partitions. A processing layer consumes events, invokes user-defined functions, and emits new events or projection updates. Exactly ANSI semantics, backpressure, and checkpointing are platform concerns. The runtime orchestrates physical partitions, state stores, and failure recovery. Fault tolerance is built in, log replication and auto failover, monitoring via causality IDs. Developers declare aggregates, events, and projections. The platform provisions everything else. This unifies stateful stream processing with serverless execution, presents the unified runtime that delivers the breakthrough as a managed, composable system. Here's something most people overlook: core components. Ingestion gateway, async protocol translation, schema validation, idempotency deduplication. Durable event log, partitioned, replicated append-only store with total order per partition. Event processors, stateless functions triggered per event, produce new events and side effects. State store, embedded key value backed by changelog, enables local stateful processing. Materialization engine, incremental view maintenance, push to hot caches. Query serving, gRPC GFL endpoints reading pre-built projections. Control plane, partition management, rebalancing, schema registry, observability. Exactly ANS enforcement through transactional pairing of processing and state store updates. This decomposes the backend into composable, horizontally scalable components. Each layer independently scales with workload, breaks the system into its layered, independently scalable components. Think about this for a second. Command and write workflow. Client issues command with client-generated idempotency key. 2. Gateway validates auth schema deduplicates. 3. Command handler loads aggregate snapshot from local state store, applies business rules. 4. On success, new event deaths are atomically appended to the log and state store updated. 5. Acknowledge response includes event offset for read your writes. 6. Event processors react asynchronously. Update projections, trigger external actions. The command handler is deterministic. Given event history, outcome identical. This enables replay and audit. Write path bounded by log append latency. Idempotency key ensures exactly ANS processing, no state corruption. Details the right side pipeline guaranteeing deterministic, exactly ANS command processing. And this is where things get complex: read, path, and materialized views. Queries never hit the event log directly. Projectors subscribe to event streams, incrementally compute denormalized views into memory and disk. Materialized views are continuously updated, serving queries with E10AIN P99 latency. Views can be replicated globally for local reads. Schema evolution handled via upcasting and forward compatibility. Read models are disposable, rebuild from log on demand. This separates read load from write processing, enabling independent scaling. Cache invalidation becomes event-driven, not timed. Consistency bounded by event propagation delay, tunable. No cache stampedes. Backpressure aligns throughput. Explains the decoupled read side that delivers fast, consistent queries without touching the event log. But here's where it gets interesting: resilience and correctness. Built-in exactly ANSI semantics via transactional outbox and idempotent handlers. Event log immutability enables point-in-time recovery and full audit trails. Failure recovery, reprocess from last checkpoint, no duplicate side effects. Chaos testing shows graceful degradation, partitioning isolates as blast radiuses, not cascading failure. State can be reconstructed from scratch. Consistency boundaries are per aggregate. No distributed transactions needed. Write-ahead log ensures durability. Platform handles retries, backpressure, and dead letters. Zero data loss guarantee. At least ANS delivery with idempotency, yields exactly on's effect. Monitoring with causality traces per request. Demonstrates how the architecture delivers systemic resilience and correctness guarantees. So, what's the real problem? Let's talk about developer experience. Domain-driven design as code define aggregates, commands, events, and projections in a single specification. SDK generates event store schemas, stream topologies, and API endpoints. Test locally with embedded event log and replay debugger. CI/CD promotes code to production with canary replay validation. Deploy new features without database migrations, just new projections. Time travel debugging, reproduce any past state by replaying events. Observability SDK emits traces, metrics, logs automatically. Declarative state management eliminates entire categories of bugs. Ship from idea to production in minutes. Shows how the platform transforms developer velocity through specification-driven, zero infrastructure workflows. This raises a critical question: global scale and multi-region. Active-active replication with conflict-free merge semantics, CRDTs. Log partitions replicated across regions with asynchronous mirroring. Client requests route to nearest region, serving local reads with causal consistency. Compute autoscales per partition based on event rate. Global state converges automatically. Strong consistency where needed via consensus partitions. Multi-region writes accepted without global locks. Latency defined by light speed, not coordination. The mesh self-balances, redistributing partitions under load. Geo-partitioning for data sovereignty, end-to-end encryption. Backend as a planetary scale fabric. Illustrates seamless global distribution with local latency and automatic convergence. Now let's zoom in on launch, the event-native backend platform. Backend engineering has transformed from assembling fragile microservices to composing reliable event-driven state machines. The platform is available now with SDKs for major languages. Build backbones that process trillions of events, survive region outages, and deliver sub-10 emirs reads. Zero compromise on consistency, latency, or developer speed. Event native is the new standard. Start your migration with a single aggregate. Scale to thousands. Join the engineers building the next digital infrastructure. Deploy in minutes. Announces the availability and invites the audience to build on the event-native backbone.